Welcome to the Waves unit for Cambridge A-Level Physics. In your mechanics modules, you studied discrete, colliding particles. Now we transition to continuous, oscillating disturbances. Waves are the universe's primary mechanism for transferring energy and information from one place to another, entirely without the net transfer of physical matter. Sitting at the core of the Cambridge syllabus, this unit bridges your understanding of kinematics with the abstract phenomena of fields, superposition, and quantum physics you will meet later. You are going to develop the spatial and mathematical intuition required to visualize invisible energy transfers, separating those who just memorize equations from those who truly understand the physics. Topics 1 and 2 establish the fundamental vocabulary and mathematics of oscillations. You will learn to classify every wave in the universe into two categories, transverse or longitudinal, by comparing the direction of particle oscillation to the direction of energy transfer. You will also map the invisible compressions of a sound wave onto displacement position graphs, extracting crucial parameters like amplitude, period, and phase difference. At the heart of this is the wave equation. You will derive and apply this to calculate wave speed, frequency, or wavelength. It elegantly connects how fast a wave oscillates in time with how far it stretches in space. Mastering this mathematics is your absolute foundation for Paper 2. Topics 3 and 4 scale up from single waves to complex environmental interactions. You will predict exactly what happens to a wave's speed, frequency, and wavelength when it reflects off a boundary, refracts through a new medium, or diffracts through a narrow gap. We also explore wave intensity, applying the strict rule that intensity is directly proportional to the square of the amplitude. Then we tackle the Doppler effect. You will use this exact equation to calculate why a police siren drops in pitch as it speeds past you, or how astronomers measure the expansion of the universe. The key to Cambridge exam success here is mastering the strict sign convention for the denominator. Topics 5 and 6 focus entirely on the electromagnetic family and its unique properties. You will memorize the exact orders of magnitude for the wavelengths of all electromagnetic waves, from giant radio waves to microscopic gamma waves. These factual recall marks are the backbone of Paper 1 multiple choice questions, and examiners love to test if you know these boundaries by heart. Finally, we look at polarization. By restricting the oscillation of a transverse wave to a single plane, you will prove the fundamental nature of light. You will calculate the exact intensity of light surviving a journey through multiple polarizing filters using Malice's law, which is a guaranteed calculation trap in your exams. By the end of this unit, you will be able to mathematically graph progressive wave motion, predict wave behaviors like refraction and diffraction, calculate Doppler frequency shifts for moving sources, and manipulate polarized light to determine transmitted intensity.